Imagine being told everything you've learned about space and time is not quite what it seems. That the clocks you trust, the distances you measure, and even the flow of time itself are not universal truths, but reflections of your own perspective. What if I told you that the universe doesn't care about now or here in the way we think it does? Today, we are going to challenge everything you thought you knew about reality. We'll dive into a world where space and time are not the rulers of existence, but merely the language we use to describe it. You will discover how motion, observation, and relationships, not space and time themselves, define the universe. By the end of this journey, you may find that the universe is far stranger, more elegant and more beautiful than you ever imagined. So stay with me, because what we are about to explore will stretch your mind, shake your assumptions, and reveal the hidden patterns that govern everything around us. This is not just a lesson in physics, it's an invitation to see reality in a completely new light. The first keynote challenges one of the deepest assumptions we carry about physics, that relativity is mainly a theory about space and time themselves. In reality, relativity is a theory about how measurements depend on relationships between observers. When we say that lengths contract or clocks slow down, we are not describing physical objects being squeezed or time itself dragging its feet. We are describing how different observers, moving differently, compare the same events using their own measuring tools. Every measurement requires a reference frame. Speed only makes sense relative to something else, and the same is true for distance and duration. Relativity exposes the fact that these quantities do not exist as universal, observer-independent facts. They emerge from comparisons. Two observers can measure the same event and obtain different numerical values, yet neither is wrong. The laws of physics remain identical for both, even though their descriptions differ. This shift in thinking removes the need for absolute space or absolute time. There is no privileged viewpoint from which the universe reveals its true distances or true durations. Instead, reality is structured by invariant relationships, quantities that remain the same even when observers disagree about measurements. These invariants, such as the speed of light or the space-time interval, are not about space or time individually, but about how events are connected. Seen this way, relativity becomes a lesson in humility. It teaches that what we often call physical properties are not owned by objects themselves, but arise from interactions, motion, and perspective, redefining reality as a network of relationships rather than a collection of fixed attributes. The second keynote pushes the idea further by questioning whether space and time are fundamental components of reality or simply conceptual tools created by the human mind. We experience the world by organizing events into where and when, but that does not mean the universe itself is built from space and time as basic ingredients. These concepts are incredibly useful, yet usefulness should not be confused with fundamentality. Physics often advances by replacing intuitive ideas with deeper structures. Temperature feels like a basic property, but at a deeper level it emerges from the collective motion of particles. In a similar way, space and time may be emergent descriptions, arising from more primitive relationships between physical processes. Relativity hints at this by showing that space and time can trade roles depending on the observer, suggesting they are not rigid or independent entities. If space and time were truly fundamental, they would exist identically for all observers. Relativity demonstrates that they do not. Different observers slice the same reality into different nows and different distances, yet the underlying physics remains unchanged. This implies that space and time are part of the language we use to describe reality. Not the grammar reality itself follows. By focusing on events and the relationships between them, physics moves away from picturing the universe as a container filled with objects evolving in time. Instead, the universe appears as a web of interactions, where structure comes from connections rather than from a pre-existing spatial or temporal backdrop, quietly shifting our understanding of what reality is made of. The third keynote emphasizes that motion, observation, and perspective are not secondary details added on top of reality, but active ingredients that shape how reality is described. In everyday life, we assume that objects simply have properties like speed, position, and duration, independent of who is observing them. Relativity dismantles this assumption by showing that these properties only gain meaning through the state of motion of the observer. An observer is not just a passive witness, but part of the physical situation. The act of measuring involves clocks, rulers, and signals, all of which are governed by the same physical laws as the phenomena being measured. When observers move differently, their tools behave differently, and so their descriptions of the same event diverge. This does not indicate confusion or error. It reflects the consistent application of physical laws from different perspectives. Perspective in relativity is not about opinion or subjectivity. It is precise, mathematical, and constrained by invariant rules. All observers agree on the underlying structure of physical laws, even when they disagree on numerical outcomes. This reveals a universe that does not privilege any single viewpoint, denying the existence of a universal frame from which reality can be fully and finally described. By elevating observation and motion to fundamental status, relativity reframes reality as something relational rather than absolute. What exists is not a list of fixed properties attached to objects, but a coherent pattern of relations that change with perspective, while remaining internally consistent across all observers. The fourth keynote addresses the deeply ingrained idea that the universe must operate with a single, universal clock ticking away in the background. Human experience encourages this belief because our daily lives unfold at similar speeds and under similar conditions, creating the illusion of a shared, absolute time. Relativity dismantles this intuition by revealing that no such universal time exists in nature. Time, as measured by clocks, is a physical process, not an abstract flow detached from the material world. Clocks are affected by motion and by gravity, and because observers move differently and experience different conditions, their clocks do not remain synchronized. This is not a flaw in measurement or technology, but a fundamental feature of reality. Each observer carries their own time, defined by the path they take through events. Without a universal clock, the notion of a single, objective now collapses. Events that appear simultaneous to one observer may occur in different orders for another. Yet this does not create paradox or inconsistency. The laws of physics remain perfectly coherent because they do not rely on a global time reference. What remains consistent are the relationships between events, not their placement on an imagined cosmic timeline. This insight forces a profound shift in how reality is pictured. The universe is not a film reel advancing frame by frame for everyone at once. Instead, it is a collection of interwoven histories, each defined by its own measure of time, all governed by the same physical principles, challenging the comforting idea of a shared, temporal background. The fifth keynote explores the idea that what humans perceive as absolute or universal is often just a product of scale and habit. Our everyday experiences give the impression that distances, durations, and motions are fixed and identical for everyone. But this is an illusion rooted in our limited perspective. On the scale of human life, differences caused by motion or gravity are negligible. So we naturally assume that time flows uniformly and space stretches evenly. Relativity challenges this assumption by showing that these intuitions fail when conditions deviate from our familiar range. At higher velocities or stronger gravitational fields, the differences become measurable and significant, revealing that the properties we thought were fundamental actually depend on context. Lengths contract, clocks slow down, and simultaneity becomes relative, demonstrating that absolutes are emergent illusions rather than intrinsic features of reality. The universe does not need to conform to human expectations. Our perception of stability is merely a byproduct of living within a narrow range of physical conditions. Recognizing this limitation allows a deeper understanding of the cosmos. Observers moving differently or experiencing different gravitational potentials see distinct versions of events, yet all versions are equally valid within the framework of physics. This teaches that consistency in natural laws does not require a universal agreement on measurements. Reality is relational, and absolutes exist only within the context of our human scale perspective, not as universal truths. By questioning what feels inherently fixed, we open the door to understanding the universe on a broader, more accurate scale, beyond the comforting assumptions shaped by our limited experience. The sixth keynote focuses on the profound insight that the deepest laws of physics emerge when we stop treating space and time as the primary building blocks of reality. Classical intuition leads us to picture the universe as a stage, with objects moving through fixed spatial coordinates as time ticks steadily in the background. Relativity dismantles this framework by showing that these constructs are not fundamental, but arise from the way events relate to each other. By shifting attention from space and time themselves to the relationships between events, a more consistent and elegant description of the universe appears. This relational perspective emphasizes that the true invariants of the cosmos are not distances or durations measured separately, but combinations of quantities that remain consistent for all observers. Concepts like the space-time interval or the speed of light are not features of space or time alone, but expressions of the underlying structure connecting events. By focusing on these invariant relationships, physics uncovers patterns that hold universally, independent of perspective, motion, or measurement tools. Viewing reality this way dissolves apparent paradoxes and contradictions. Conflicting measurements between observers do not signal confusion in nature, but highlight that space and time are descriptive, not absolute. The patterns of connection, the web of events, and their relationships constitute the true fabric of the universe, with space and time functioning as emergent language for human understanding. This shift from substance to relation encourages a deeper comprehension of the cosmos, revealing that reality is defined not by static coordinates or ticking clocks, but by the consistent and invariant network linking all events together. In conclusion, the journey through relativity reveals a truth that is both humbling and exhilarating. Space and time, the pillars of our everyday understanding, are not the universe's ultimate foundation. Instead, reality emerges from relationships, perspectives, and the connections between events. What feels absolute, distance, duration, simultaneity, is only a reflection of our limited human scale and habitual assumptions. Relativity teaches us that the universe is far more elegant than we imagined, operating through consistent patterns that transcend our intuition. By shifting our focus from space and time to the underlying invariants and relationships, we glimpse a deeper, richer understanding of the cosmos, one that is precise, consistent, and profoundly relational. Thank you for joining this exploration into the nature of reality. Embrace curiosity, question assumptions, and never stop marveling at the hidden structures of the universe. Good luck in your journey of discovery, and may your understanding continue to expand beyond the boundaries of space, time, and imagination.